Hi children, welcome to my YouTube channel. This is the fourth video of the topic series Representation of Data. In this topic, we are going to discuss about skewness. What do you mean by skewness? If you get the day-to-day data, we can see some of the data may be distributed symmetrical. Some of the information may be deviated or we call distort into one side as shown over here. If the given set of information is distribute or distort into a certain side from its symmetrical axis, we call those are skewed information. Our objective today is to identify the skewedness and the related properties in this video. Initially, if I come up with the symmetrical data. In this example, if you plot the information in the table in this bar chart, you can see this information distribute symmetrically like a bell shape. There is this set of information is evenly distributed, symmetrically distributed. This kind of sets are called the symmetrical data. If the information is symmetrical, we call it is zero skewed information, or we call the skewedness become zero. How do we identify a symmetrical data without drawing a bar chart like this? The first property we can see is the mean, median, mode. We know that these are the three measures of central tendencies. Those are similar to each other if the information is symmetrical. There is another property where we can understand. If you draw a box plot and you know that the first value is the first quartile, the second line is second quartile and third line is third quartile. If you get the gap between second quartile to first quartile and third quartile to second quartile, those gaps become similar if the set of information is symmetrical. Right. From these two properties, we can get a rough idea whether this set of information is symmetrical or not. Later on, we will learn how to get a numerical solution to understand whether this set of information is symmetrical or skewed. If the set of information is symmetrical, we can use the mean as a measure of central tendency. And we use the standard deviation as measures of dispersion. We know what we mean by measures of central tendency and measures of dispersion from our previous topics. Then, if the information is symmetrical for such data, we can use normal distribution in our probability calculations. Those are the main properties and the facts where we can learn about symmetrical data. Then we will come up to positive skewed data. If the information is deviated or distorted towards left-hand side, we call those informations as positive skewed data. For example, if it's shown somewhere like this, right? Then if this set of information is positively skewed, what are the facts where we can understand, right? Then if this information is not symmetrical data, it should be positive skewed. I think I made a mistake, right? If the information is we can correct over here. It's 4. Okay. For positive skewed data, we can observe following properties. The first one is the skewedness become positive. The skewedness become positive because obviously we know that The skew, positive skew means skewness become positive, nothing to say over here. But later on we will learn how to calculate this skewness, right? Then we can understand the second property is the mode is the smallest figure, then median, and the largest figure is the mean. So if you calculate mode, median, and mean, you can understand that you will observe a lowest figure for mode, then median, and the largest figure become mean. Then if you draw a box plot, and if you get the gap between second quartile and first quartile, the gap from here to here, and if you calculate the gap from here to here, then you will understand that here the gap become pretty smaller than the gap over here. That is the second property where we can understand if the information is positively skewed. Generally we use these two conditions to check the get a rough idea about the skewness, right? If the information is positive skewed, we can use mean or mode as a measures of central tendency and quartiles as the measures of dispersion. For a skewed information, we cannot apply the normal distribution to calculate the probabilities. Okay. Then we will come up with the negative skew data. If the information is negative skew, how do you identify? You can see if I plot the information in a bar chart over here, the information skewed towards right. You can see the information is skewed somewhere like this towards right. That kind of information are called negative skewed data. How do you identify the negative skewed data? Right. If the information is negative skewed, okay. For a negative skewed data, we can observe following properties. The first property is skewness become negative, obvious figure. Later on we learn how to calculate the skewness. Then we see the opposite property of the positive skew. Then the first property is the mode would be the highest figure, the median would be the next figure, and mean would be the smallest figure. If this follows up this condition, we can say it is skewed data. Then if you get a box plot, you can see here the Q, this is Q1 value and this is Q2 value. You can see here the gap is quite larger than the gap from Q2 to Q3. Then if you get the gap from Q2 to Q1, that gap become pretty larger than the gap between Q3 to Q2, right? For this kind of information, even for the negative skewed data, even you can use the median or mode as a measures of central tendency and quartiles as a measures of dispersion. This property is common for negative skewed data and positive skewed data as well. Then in our previous slides, we discussed about skewness. All the time we talk about skewness, but how to calculate this skewness? This is the way of calculating the skewness. There are two common formulas we use to calculate the skewness, but the general, most popular formula is this. Skewness you can calculate. This is 3 times of. There's something missing over here. It should be 3 times of. Yeah, 3 times of mean minus median divided by standard deviation. We know how to calculate mean, median, and standard deviation from our first videos, right? Then this is the first formula we use to calculate the skewness. First, you can calculate the mean, median, and standard deviation for that set of data. And if you put into this value, if you get a positive answer for k, that means it's a positive skewed figure. Then if you get a negative value for k, that means it's a negative skewed figure. And if this k value is 0, we can call it as a symmetrical information. Then for symmetrical information, if you want to make this 0, we need to understand that obviously the numerator must be 0. If the numerator is 0, but you can understand mean is similar to median. Mean is similar to median. Therefore, if in a set of information, if mean value and median values are same, we can say those are symmetrical information. Apart from that, if the mean value is a positive value, we know that obviously standard deviation is a positive answer. Therefore, If mean is bigger than median, we can say it's a positive answer. Okay, that means for a positive set of information, we can say mean is larger than median. If mean is smaller than median, you get a negative answer for this bit. Anyway, this value is a positive value standard deviation. Then if the mean value is smaller than median, you get a negative answer for k. That means you can say if mean is smaller than median, we call it as negative skewed data, right? These are other formula we use in our certain applications. We can use this formula also to calculate the skewness of a given set of information, right? Okay. Then to get a rough idea about the skewness, we can use these box plots. In a box plot, if this is just like what you call that symmetrical, if these gaps are similar, but you can understand that that set of information is symmetrical if these gaps are similar. Then what happen? Like suppose that this is just like a small rubber box. If I squeeze from this sense, what happened? This goes up. That means you can see if you squeeze from these two corners, this what you call this thickness get reduces and this goes up. Then what kind of information is that? You can say just like a heap you can see over here. What kind of information related with this kind of what you call a graph with a heap over here, just like this. If I squeeze from here, this goes up. This become much narrower and this goes up. That means you can see a distribution somewhere like this. What is that distribution? You will obviously know that that is positive skewed information. For positive skewed information, if this gap is small, that means this end is squeezed and this has gone up. That means this is positive skewed. The negative skewness is opposite. That means if I squeeze from this terminal or this what you call the gap between Q2 to Q1, what happened? That become narrow and this side goes up. Therefore, what happened to this information? It goes somewhere like this. What kind of a distribution is that? Obviously, we know that that is negative skewed information. So, if you get a no gap, what you call narrower gap over here, we can say it is as a negative skewed information, right? Okay. This is the simple idea of identifying the skewness, or to get a rough idea about skewness using a box plot. These are the common concepts where we have to learn under skewness, right? Hopefully you have understood the contents in this video. If you like this video, put a thumbs up and share this video with your friends. To watch more educational videos, please subscribe my channel and click on the bell icon. See you from next videos.